Bonjour à tous les amis and bienvenue to a new video of Amazing Max Stuff. In this video, we're going to answer a question which I received a couple of times too much to not make a video about it. And the question is, how can we deal with draw mode lines in a GGL mesh with having light width and using a custom shader for the GGL mesh? So let's say that you have a GGL shader called Shady and does some stuff, and you attach it to this GGL mesh, and then you suddenly find out that your line width doesn't work anymore on your GGL mesh, so they will just draw lines that you cannot make bigger. And also, actually, one thing is that these lines don't have depth, so if you go farther away from the lines, they will stay the same size. So how to have line width in a custom shader and how to set the depth for these lines, and also how you can still apply texture to your GGL mesh using your custom shader. So we're going to answer all these tricky questions in this video. So strap your seatbelt and let's dive in. Now, as you can see, I got here just a JIT world with a camera, and then we got a GGL mesh with draw mode lines. We got noise with 3 planes, of course, X, Y, and Z for the positions, and 100 cells, and 100 cells as well for the color. So actually, when we draw with draw mode lines, every line has actually 2 vertices. But we are sending 100 different colors, but nevertheless each line has its own color. So this is because it's not interpolating the color between the 2 vertices, because we are not using smooth shading 1. If we would use smooth shading 1, you will see that it's interpolating the colors between the 2 vertices of the line. So that's another cool thing to know. So as you can see, it's interpolating the colors between the 2 vertices of the line. Good. But anyway, we're going to write our own custom shader, so we will not have access to smooth shading. It becomes useless. So let's do that. So first of all, let's get the current shader that is inside GGL mesh, because this is the one we're going to start from. This is going to be our layout. So I'm just going to click into this message, get GL3 shader. I'm going to copy the whole thing. Again, I'm going to create a new file on Visual Studio Code. I'm going to pass this whole code that I just created, and then I'm going to save it inside the desktop as all files, and I'm just going to replace a previous shader which I created, which is called draw_mod_lines_width.jxs. I want to replace it, yes. Then I'm going to change the highlighting for the shader to GLSL inside Visual Studio Code. And great, as you can see, this code has a lot of empty space, which we don't like, so we are just going to make it a bit prettier, because this code is automatically generated by Max, right? It doesn't really care about making the code pretty. It just cares about making it work. So we actually do care about making it a bit more readable. So we're going to delete all these empty lines, and let's give it a go. So let's analyze this shader that was automatically created for us by Max. We got a vertex program that just takes care of passing the GL position multiplied by the model view projection matrix to the next stage, which is in fact a geometry program, is a geometry shader, which takes as inputs our lines primitive, so the primitive passed from the vertex shader, and gives us an output triangle strip. So what's happening here, when we do line width in GL3, what's happening is that it takes a line as input, the shader, and then it creates four vertices and replaces the 2 input vertices with these 4 vertices in order to create a rectangle. And then we can choose the size of this rectangle in order to give to the lines a certain width. So that's what this geometry program is doing. It's getting as input the 2 vertices, and then it's using those 2 vertices to create this rectangle. Actually, this emit vertex is connected to the fact that we are creating a new GL position, so it should actually be closer to here than to the next lines. And then after we emit the 4 vertices, we end the primitive and we go to the next stage, which is the fragment program, right? The fragment program is simply outputting the color of the vertex that it receives from the previous stage. Okay, great. So first thing first, what we're going to do now is to modify this shader in order to give a depth to the lines. First, we need to actually load this shader inside this shader object. So we say file, and I believe I called it draw mode lines width.jxs. So file draw mode lines width.jxs. So now if I double click on this file, it should automatically open it on Visual Studio Code, exactly. And let's apply this shader to the GGL mesh. If we do that, we should actually see no changes into how the GGL mesh works, because we are exactly copying the shader that it was already using. So there should be actually nothing different. Let's refill the vertices and the colors. Let's change the line width. And as you can see, it's working exactly as before. But as we say, those lines don't really have a depth. So when we go farther from them, they still are the same size. So in order to change that, we are going to do something that was actually an idea from one of my patrons, which is really great. We are going to, well, you're going to see what we're going to do. But first of all, what we need to do is to actually get a line from another automatically generated shader. So let's copy that. This stuff, and instead of draw mode lines, let's give it draw mode points, and then point mode circle depth. Right? So now we have a bunch of circles here in our world, even if you cannot see them because they're really small. But now if we get the shader from here, we can see that there is this line to set the GL point size. So this is the size of the circles according to how far they are from the camera, which is great. This is what we need. So we copy this line, we delete this stuff, we don't need it anymore. We go inside our shader, and in the vertex program, we copy this line that we just copied from that automatically generated shader, right? And we don't call it GL point size. This is something that we're going to pass to the geometry shader. So in order to pass stuff to the geometry shader, we need to fill this structure that was automatically created by Max, which is called jit per vertex. And this is just a structure that we are passing as an out, which means it's going to the next stage in the pipeline, which is a geometry shader. The geometry shader has an in structure, which is called exactly the same. It's important that it's called exactly the same, otherwise it will not work. And this is actually an array. It creates an array for this structure because every vertex has its own input structure. That's why it's an array, because the geometry program is not receiving a single vertex in the input, it's receiving an array of vertices according to how many vertices there are in the primitive that we choose as input type. Since our primitive is lines, there are only 2 vertices to form a line, so there are 2 vertices in this array, so there are 2 structures inside this array. Great, so let's create a new variable inside the structure, which we will call flat. We will give it the attribute flat, which means basically it's not going to be interpolated between this stage and the next stage in the pipeline, so between the vertex shader and the geometry program, and it's going to be a float, and we're going to call it like line size. And then we have to copy that structure variable inside the geometry program. The 2 structures must look exactly the same. The variables must also be in the same order. I cannot put that above color inside this structure and below color inside this structure, right? They must look exactly the same. So we can then fill this variable here. So inside our main function, we say jit out line size is equal to point size. Well, this is actually a variable that we don't have. We have to replace that with line width. Now, line width is a parameter that gets passed to Max to our shader, but is only being pinned to the geometry program. So we actually need to copy that line and bind it as well to the vertex program. So inside here we create a new uniform, which is a float, and it's called line width, and then we use actually that line width instead of point size. And great, so now our shader should have complained because we did some stuff wrong, and then I saved, but actually now should be all good. Okay, it's working. We still haven't got the depth because we actually need to use this line size. So, as my Patreon suggested me, this was a great idea, we can just divide, actually multiply this value, which is actually the offset of our rectangle. So it's the width of our rectangle, basically. Actually, it's half of the width of our rectangle. And this defines how wide is going to be our line. And this we multiply that by jit in, and since we say this is an array, we're working now on the first vertex because this is P0, so it's related to the first vertex. So we are working on the two vertices that are going to replace the first input vertex. So the two output vertices that are going to replace that vertex here. And we're going to say jit in 0 line size. Okay, and we're going to copy that and paste it also on the line below, because we're going to do that also for that vertex and then also for that vertex here. But now we are working on the vertex here below. So we need to say jit input 1, because this is the other vertex. So we say jit input 1 line size, and the same here. And this should be good to go. So I'm just saving now, going to max. And now, as you can see, when we go farther from the lines, they get smaller and smaller. So great, mission accomplished. And this was a great tip. I should have researched for that, but this was provided to me for free. So it's worth to spread to the world, I think. Now we have depth for the lines. Good. Now let's see how we can apply a texture to define the colors of our lines instead of just passing it to the buffer, to the color buffer of GGL.mesh, because this is a matrix, so this could be slow. If we want to update these colors at every frame, this could be slower than actually using a texture. So we are going to create a texture here, and actually let's create a two-dimensional matrix, so we will have two-dimensional coordinates for the texture. And let's create, I guess, a JIT movie with our good chickens.mp4 file. Actually, this is called movie file. And output texture 1. So this is going to output the movie chicken as a texture. There it goes. And let's create a new GGL texture object. Let's give it a name. Let's call it like movie text, something like that. Right? So we're going to pass this texture to our GGL mesh, so we can use it inside the shader. So texture, we're going to say movie text. Cool. Every time we modify the shader, we need to refill its values. Let's maybe give it a default line width of 10, something like that. So we have to refill its values with colors and stuff. Okay. Great. So now, inside our shader, we can do something like that. We can create a new parameter, which is going to be our texture. So param name, and we can call it whatever we want. I will just call it movie text to, I guess it makes sense. This is of type integer because it's actually the index of this texture inside our object. And since it's the first texture and only we have its index is 0. And then here we have to bind it. So we're going to bind it to the fragment shader. So this is called movie text and to the program FP. We want to bind it to the fragment shader because this is going to define the color of our lines, which is then set into the fragment shader for sure. So we're going to the fragment shader here, which is the last program we got. We can create a uniform whatever we want before the main function. So this is of type sampler to the rect. That's the type of a texture in GLSL, and it's called movie text. Okay, great. So now we need to read it inside the main function. So we can do something like vec4 movie text color, and this is we're going to read it using the built-in texture function, and we have to say what we want to read, so the movie text, and then we have to use some texture coordinates. But texture coordinates we don't have, because we have to pass them all the way from the vertex shader down to the fragment shader. So first of all, we actually need to get them from our GGL mesh object. So we have to create a new parameter, and let's call it text coord. and this is of type vector2, so texture coordinates are always type vec2, and this is also from the state, which means is automatically generated by max, and is a variable that max passes to the shader, and it's called textchord. So to access this variable, we have to write state equal textchord, and then we have to bind it to whatever we want to use it, which is the vertex program. So it's to say textchord, which is the name of the variable we created, bind it to the vertex program. And in the vertex program, this is of type in, because this is a buffer that our GGL.mesh passes to the shader. This value is different for every vertex. That's why it's not a uniform, which means is uniform for all the vertices. This is an attribute, which means is even written here. So attributes, it means it's different for every vertex. It's an attribute of the vertex. So this is of type vector2, and it's called textchord. But that's not enough, because actually we also need to get texture matrix to multiply these texture coordinates. So let's get the texture matrix as well. So it's called param name, and we will call it texture matrix 0, something like that. This is of type mat4. This is a type that we have inside GLSL. It's basically means it's a mathematical matrix of 4. It's used to make transformations, and this is called I think it's called texture 0 matrix. I think it's called like this. I could be wrong, but you know, there is one way to find out, which is going to max in the help in the reference, going searching for GLSL documentation, and then I guess there should be like the GXS file format exactly, and this should tell us what are all the state variables we can have access to. And let's see, these are all the matrices, I think. And there we go, texture. So texture, then the name of, so the number, the index of our texture, in this case it's 0, and then matrix. Okay, so I think I wrote it correctly, exactly. So then we have to bind it, and we're going to bind it as well to the vertex program. So bind param, we called it texture matrix 0, long name, isn't it? And we bind it to the program to the vertex program. There we go. And this is actually a uniform, because it's not different from every vertex. This is the same for the whole shape. So this is a uniform. So this is a mat4 texture matrix 0, right? And so in order to pass these texture coordinates to the fragment shader, we need to do like we did for the line size. We need to create a variable inside our structure and then pass it to the structure in the geometry program. And this we'll call it textchord 0 or something like that, because it's our first texture. And then here we can say jit out.textchord 0 is equal to, and now we need to multiply our texture matrix. So texture matrix 0 by our textchord, but our textchord is actually a vector 2, and this is a math4, and we cannot multiply a vector 2 by a math4 by default. We need to first make this vector a vector 4. So in this case, we need to give it as the zeta and w values, a 0 for the zeta and a 1 for the w. This is very important. But then what we need to get out of that is just a vector 2, so then we include this in parentheses, and we just take the first two components, the x and the y, for the textchord, which is actually a vector 2, right? I hope it makes sense, because it does make sense. I hope I'm actually explaining it clearly enough. But if you don't know about this stuff, you just need to study it, right? You just need to go on the internet, Google this stuff, and you will understand everything, because it's all out there. So inside the geometry program, we have to write the same variable inside the structure as well. And here we need then to pass that inside the out structure of the geometry program, because this is the structure that then goes as input in the fragment shader. So we need to create here, I guess, a new flat variable vector2 textchord. Let's call it again textchord 0. And we need to copy that as well inside our input structure in the fragment shader. And then here we have to say, inside the main function of the geometry program, we have to say, in this case, this is pretty strange because we didn't give a name to this structure, so we can actually access the values inside these structures without putting like jit in dot, because there is no name for that structure. So test code 0 is going to be equal to jit in oh, actually, you know where we don't need to put this here. We need to put it inside each vertex emission, because we're going to emit each vertex separately, so we actually need to, for each vertex, we need to output its own texture coordinates. So this is going to be jit in 0 text coord 0 here, and we need to do it as well inside the second vertex. In the third vertex, we actually want to access the second the structure for the second vertex of the lines input, and as well in the fourth vertex. Good. And now here we got right, this should actually work. Let's see. So if we write jit in dot text coord, and then we say we use the movie text color instead of the jit in color for the color of our lines. Let's see what we got. We got probably some errors. So let's see what's going on. Text coord is not a member of strat jit per vertex, right? Because we actually called it text coord 0. So let's see if this actually works. And it could actually be that it works. Yes. It does work, but we don't have any texture coordinates inside our GGL mesh, because we are accessing them from the shader with this state text coord, but we actually never passed that to our GGL mesh because it doesn't have texture coordinate by default, differently from GGL grid shape, which has texture coordinates by default. GGL mesh doesn't have anything by default, so we need to provide them manually. So let's actually create this quickly a jit.gen object here, and let's do like this. We will do this mapping thing inside a jit.gen. So for the first input, we say scale 0, 1 to -3, 3. Right, this is going to be the vertices position. And actually, we don't need a second input, but we need a second outlet, because the texture coordinates are just going to be the normalized coordinates of each cell for our GGL mesh. So we just need to send these out, and cool. Wait, it's working. So now that the color, it's not really being used anymore. We are not really using anymore the color for each vertex, because now we are using the color of the video input for setting the values, the color of the lines. Actually, I'm pretty curious what will happen if we will not set this to flat when we pass it from the geometry program to the fragment program. So let's try to take the flat away, because this should then make an interpolation. Oh yeah, this is now making an interpolation of the color through all the fragments between these four vertices. So I guess this looks pretty cool. So, mes amis, le tutorial c'est fini. I will see you in the next one, hopefully, if you haven't been scared too much. If you could put a like to this video, it will be much appreciated. If you will follow the channel, it will be even greater. And if you will check my Patreon, will be like the greatest thing ever. So there you can find a lot of patches and get in contact with me. And yeah, get access to all the shared content that I have on Max and Jitter. Thank you very much again, and see you soon in a new video. Ciao, ciao.